Right, the next section looks at the multiplication rules. And what the multiplication rules show and look at is what happens when you have a series of events happening. So for example, the special rule of the multiplication says basically it's the probability of one happening after the probability of another. So this is where that language again becomes important. Probability of A and B happening. So it's a series of events. So in the case of this example, what is the probability of rolling 3 sixes in a row on a six-sided die? So we know that the probability of rolling a 6 is 1 divided by 6. And we can do that all the way down. Now, if we were to follow the addition rule, it would be simply a matter of summing it all up, and we'd have an answer 0.5. Well, that's not true. We don't roll 3 sixes in a row 50% of the time. That's not correct. So what we do is we multiply things. So it's going to be equal this, and to get the little star sign, it's shift 8 times that one, shift 8 again, times this one. And that will give us 0.004, or a little less than 0.5% of getting 3 sixes in a row. And that makes a little more sense. It's not very common to see 3 sixes thrown on a six-sided die 3 times in a row. So that's the special rule of multiplication. The general rule of multiplication states that probability of A is happening, and then we have a conditional probability associated with it as well. So a jar has 5 blue and 5 red gumballs. What is the probability of selecting 3 blue gumballs in a row? Okay, so our initial condition basically states that there are 5 blue and 5 red. So 5 blue out of 10 total, 5 divided by 10. That is our probability. Okay. Equals 0.5. Now let's assume that we have taken 1 blue away. Now, what do we have instead? We have 4 blue, 5 red, for a grand total of 9 instead of 10. So the probability now becomes 4 divided by 9, because there's 4 blue, 5 red, so the odds are going to get a little bit less out of 9, so 0.44. That makes a little more sense. Now we're going to set another conditional probability. That's all this little symbol means is some sort of condition has been met, or some new rearrangement has been created. So now, instead of 4 blue, we're going to have 3 blue and 5 red. So equals 3 divided by 8. 3 plus 5 is 8. There are 3 blue left. 0.37. So every time we select a blue, it becomes more and more difficult to get one at random, or the odds become smaller and smaller. And so the probability of selecting 3 blues in a row becomes this times this times this one, for a grand total of 0.8, or 8% chance of getting 3 blue gumballs in a row when you have 5 blue and 5 red gumballs. Okay. And this brings us to Bayes' theorem. Probably the most complicated section of probability. In examining Bayes' theorem, part of the problem is terminology and what in the world are we asking. So I've created 3 different ways of finding it. The first one is through a contingency table. The second one which is this little guy right here. The second one is this tree diagram, and the third one is through an equation. This is actually Bayes' theorem, whereas the rest of them look at all the different options or part of the options. So let's go over some of the terminology. Probability of A, this is the probability of a single event happening. The conditional probability, very much like our multiplication, is when something is happening or there is some condition changing the odds. So that's going to be our B of A. Our joint probability is when one thing happens to it afterwards. So in other words, probability of A and B happening, which will end up being this times this, and then the posterior probability is this divided by all the conditional probabilities. But we'll go through that step by step. And so what we'll do is we'll figure this out as well as this one the next video, and then probably the third video we're going to be looking at Bayes' theorem all on its own. We'll be using these to check each other's work and to find the answers.